zone you're in. We really appreciate you taking the time to join us and talk about stateful mocking today. It's a really cool one because at WireMock Cloud, we do obviously API mocking and service virtualization. And stateful mocking, I think, is something we're really excited about because it really gets to a bigger value proposition for all of this. And it starts to look at API mocking as a true way to change how your testing platforms are built and how you go through the development lifecycle, building and managing new APIs and managing production. So we'll take a look at all of that in a minute. We'll get a great demo of it. Just as a reminder, WireMock Live is a monthly series. So every month we have new topics. We invite you to participate in Q&A. It can be on the topics. If you have questions today on stateful mocking, you're welcome to ask those. But if you have any other WireMock Cloud questions, you're also welcome to ask those. Just use the Q&A feature in Zoom, and we will make sure we get to them. We will send this recording out to everyone after the fact as well. One other note, so my name's Ethan, I work on product here, and as we're building things like this, we love to work on things hand in hand with customers as design partners. So if you see this, if you have notes, if you have feedback or anything else using the product that you want to chat about, just reach out. That's our preferred way of working, is really, really closely with our customers and users. And with that, I will hand it off to Dan. Dan is the head of customer success here at WireMock, and we'll let him take you through our new stateful mocking.
Great. Thank you, Ethan. Let me get my screen shared here, and we'll get moving. Do a little cleanup so I can see everything. All right, great. So yeah, I want to take you today through several examples of stateful mocking. We'll parse through them at a pretty slow pace at first, and then we'll go a little bit high level as we get a little bit more, let's say, powerful, to say the least, right? So first, I think a great place to start is what did WireMock have before we released stateful mocking? So one thing I pulled up here is an older demo of our scenarios capability that many of you might be familiar with. Now, you may have noticed a couple of changes in the WireMock Cloud UI when we released this feature. What used to be called the scenarios panel is now called state. And when we expand that, you'll still see the traditional scenarios configurations. So a scenario still exists, still backwards compatible. Scenarios allow you to keep a basic state machine inside of your mock API endpoint. And the typical example that we would use in demonstrating a scenario was much like this charging API that we have here, where we needed to keep track of what is the status of a particular charge by its account ID. And one of the challenges that customers had in this approach is that each charge, like this charge ID 1, 2, 3, 4, 5, might need to have its own status, right, of success or failure. And a basic state machine that simply moves a state called payment from started to success or from started to failed was good when you were only dealing with a single charge ID, but it became very challenging when you had multiple charge IDs that each needed to have their own status, or you had a shared environment where multiple people might be using charge ID 1, 2, 3, 4, 5 and expecting it to be in different states at different times. All of these challenges are now solved with stateful mocking. And you'll see a blending of dynamic state in terminology and stateful mocking as we work to solidify the naming of that. But to enable this feature is simply as easy as checking this box on dynamic state. So at this point, we'll move over to some specific examples for stateful mocking. So this is a very similar style of API. In this case, we are keeping track of an account balance, and we're going to be issuing debits and credits to it. So it's important here that every account ID maintains its own balance, right? And that state, if you will, is maintained across executions, so that if we credit an account for $10, that the next time we ask for that account's balance, it should be $10. And then if we debit it to, that should be reflected as $8 the next time we get that balance. These are the types of use cases that stateful mocking helps out with. So to walk through this a little bit, I want to showcase what's going on here. So we have debit credit account, post endpoints, and then we have these two get balance accounts. And we'll start by taking a look at the get balance account here, because I want to showcase that when we enable our dynamic state or stateful mocking, we get two capabilities. One is request matching, and the other one is state operations. So the terminology here that we'll be talking about is a state has both a key and a value. And there's also a third part called a context that we'll expand upon as we talk here. So what we're doing in request matching is we're actually interrogating the mock API to ask, what is the current state of the balance key? And simply in this stub, we're looking to ensure that the balance has been established before. So in this mock API or this real API, you can't have a balance unless you've initiated the account with an initial deposit to that account. So in this case, we've got two different stubs. One is testing to make sure that there is a balance, the initial deposit has been made. And if there actually is a balance that has been made against this, we can go ahead and extract that balance. And I'll parse through these in a little bit as we move on here. Our other get balance is simply not looking at the state. It's got a lower priority. As a reminder, priorities say that if two stubs match, then which one should win out? The lowest priority, or I should say the highest priority with zero-based priority. So 1 being the highest and 99 being the lowest. A 6 has a lower priority than a 5 here. So what we've configured is, yes, this get on accounts is the same as this one. This one will only match though if the other one that has a higher precedence hasn't matched first. And down here, we're simply saying the count is not initialized. So this is to demonstrate that we can interrogate inspect an existing key value to determine if a stub is a match or not. The other part of the stateful engine is the state operations section. So in order to set or delete a current state in memory, we use the state operations. So again, you can see we're dealing in key value pairs here. So the key of this state is called balance, and the value is being set in this box over here. Now, this is probably a good time to talk about the context. So remember that problem that we had with the traditional scenarios where we were only maintaining a single state in the state machine. But the challenge we needed to solve for was that every account number really needs to maintain its own state. And that's what we do with the context of a dynamic state or stateful mocking. The context ties the key and value of the state to some other piece of information. So as an example, in our mock API here, we want to ensure that every account ID maintains its own balance in the mock API. So for our context, if I click into this, we can see that we are going to refer to, using handlebar helpers, the account ID and tie the balance to the account ID that's being passed in on the path. Now you'll also notice this call out for a default context. When we choose default context, that's referring to the context that can be found inside of the settings here. So if we were to scroll down, we can see that there's a new state setting with a default context. Now, where would this come in helpful? Well, a lot of times when we have a shared environment, maybe a sandbox, we want to set the context to maybe the API's authorization key that's being passed in on the headers. And that might be good enough to differentiate the state between one user of the mock API and another. There's a lot of other use cases, and I'll show these as well as we walk through additional examples today. But that's the difference there that you're seeing, the default context and the custom context that you see being specified here. Now, in our example here, in order to reflect, okay, what should the balance be set to upon a debit or credit, inside of our value box, you'll see that we can make use of all of our handlebar helper library to compute the value that will be stored in here. So in this case, you can see we're making use of multiple different handlebar helpers. The first one being here, the arithmetic or mathematics handlebar helper. In the case of a debit, we're going to be subtracting two different values from one another. Then the two values, let's talk about those next. We'll see here the first value, the original value, right, would be the previous value. So this is a keyword in the stateful mocking engine. Previous value will extract what is the current value when the stub was matched of the key, that balance key that's tied to the account ID. You'll see here that we've also coupled this with a value handlebar helper. The value handlebar helper basically does a test on the previous value and says, if there is a value in there, go ahead and use that value. But if it is null, then go ahead and assign it whatever we have specified here as the OR condition. So this is basically saying, if the balance hasn't been established yet, set it at 0. But if there is a non-null value currently in this key value pair, use its value in this place. And then our next part here is simply using another handlebar helper, our JSON path handlebar helper, to extract the debit attribute from the request body and use that in the mathematics or arithmetic handlebar helper. So to see this in action, I'm going to first reset my state. Just like in scenarios, reset state clears out and resets all of the state engines, including the dynamic state or stateful mocking, back to all nulls with no key value pairs being stored. And from now, I can open up the test requester, and we can see it's going to default to account 0, and we can make a request on account 0 and see that that account's not initialized. So we looked at it and evaluated this get balance for account. It saw that the value was null for the balance, the key value pair that is tied to the account ID. So this stub did not wind up matching and instead fell back to our not initialized. So let's change that by doing our initial credit to the account. We can come up here, go ahead and make a credit to our account. We'll go 200. So as programmed, this is a 204 no content, so a successful post here. And if we go and get our balance for that account again, account 0, we can see that for account 0, my balance is 200. But if we go and ask for a different account, just going to type in a random number, 567, we can see this is a 404 not found. The account has not been initialized. So we are successfully using that context, maintaining a different balance for each one of these accounts, account 0 and account 567, and any other account number that we might try, are all maintaining their own account balance behind the scenes as a key value pair. So we can layer onto this now a concept that I like to call double contexting. So we saw how we set the context to the account ID, and that's great typically, right, in an environment that is shared across a single team or just a few developers. But what about sandboxes where we might be publishing an API to our customers and we have multiple customers that are sharing that sandbox? And it's not outside the realm of possibility that both customer A, B, and C all want to use account 1, 2, 3, 4, 5 or account 0. And we don't want their data clashing with one another. Well, thanks to contexting, we can do that pretty easily simply by coming down, and we'll take a look at our context here. So everything else in this mock API is the same. We simply have changed the context. And I've blended these two concepts together, where I'm simply going to take a look at the authorization key, right? So this would be their API token or authorization string, and coupling that with the account ID. So this assumes that customer A will have a different authorization string to access the Sandbox API from customer B and customer C, therefore guaranteeing uniqueness in the context so that all three customers or all N customers can use account 0, can use account 1, 2, 3. But because they have different authorization strings in the headers to access the mock API, they actually wind up with completely unique contexts, maintaining balances successfully, even though they're reusing the same account ID. And if we notice down below, one quick thing I will point out is, and I haven't touched on just yet, to recall the values for, in our dynamic response templating anywhere in the response building, you'll see those same concept of using the value here. So again, testing to make sure that it's a non-null value. If it was null, go ahead and just print 0. But if it's a non-null value, we're going to retrieve the state of the balance key value pair. And then we're going to provide the context here. And the context, again, is that double contexted string that we saw when we were setting the value. Now, what's really helpful in these is if we come into the request log and take a look at some of those accounts that we just did. When we did our get on account 0, we saw that we had that error of account not initialized of 0. You'll notice that we've added some specifics when referencing dynamic state events. So in this case, we were requiring for this to be a match, right? That the required state of the balance needed to be something. But in this case, the key wasn't found yet. It hadn't been stored. Remember, we had reset the state and it was a null value. That's why we fell back to our other stub. If we come into the post, we can even see where we are setting those dynamic states to help us in our debugging. So we successfully see a setting of the balance key that had a context of 0. Remember, that was our account ID that was being passed on the path. And the result from what was posted, right, the credit of 200, we stored a 200 inside of that. And then, of course, we can come to our get, and we can see that as information, again, being repeated as some helpful tips there of figuring out what is happening behind the scenes with our states. Now we have a couple of other examples I'll walk through a little bit quickly here so we can get to some questions. These are a little bit more advanced and demonstrate how the state machine, right, stateful mocking can store just more than just integers or strings. We can even store collections, right? JSON collections, JSON blobs, XML. You can store base64 encoded strings inside of state. You name it, you can pretty much store it inside of those state variables. So this is a very detailed example, a stateful shopping basket demo that is built out, inside of our documentation. So if you come into our docs.wiremock.io, and you kind of come down to the bottom, you'll see that in the dynamic state, you'll find the basics on how this works, explaining some of these concepts in detail. But you'll also find this shopping basket example walked through in very detailed format. So you'll see in here that we walk through the behavior of how we can replicate a shopping cart or a shopping basket using dynamic state. As part of this, you'll notice coming down here that we are working with storing JSON blobs inside of the state machine. So you'll see in the case we're storing the basket items as a collection. So here, instead of defaulting to 0 like we saw in the balance example, we're defaulting this to an empty collection inside of the basket. You'll see examples here of using some of our JSON parsing handlebar helpers to help us understand, well, how many items are inside of the cart. You'll even see some new handlebar helpers such as JSON array add and JSON delete, which allows us to add and remove JSON objects out of JSON collections that are stored inside of our stateful engine or anywhere inside of the WireMock cloud product. So I recommend taking a look at this very detailed example here as it walks through how things are pieced together and how things are moving in and out of the state and the various different state pieces that are there. And the best part about this is we've also released this as a public template. So you can click on this link here and it should take you to your account and be able to instantiate a copy of this dynamic state shopping basket example in your own WireMock cloud account. A couple more quick examples here. You know, this one here is an example of mocking the Azure Blob Storage API endpoint. So in this example, we needed to maintain, you know, not only being able to put something into blob storage, but then also be able to get a listing of all of the information that is currently, you know, all of the files that are stored in blob storage. So not only the put, but for the get. So we want to maintain all of those updates from those puts. And we do that, similar example. So here we can see we're just using the default context. We're maintaining a collection of files. And here's an example of a JSON array add, where we'll simply look at the file name that's being passed in from the path and add that into the array. So this will be additive, right? We'll keep adding files, so that when we do the get, we can return a list of the files that are stored in there using the proper format. So we can see that we are going to retrieve the state of the files key value pair, and then we'll do our XML response, and then we'll look at each one of the file names that are part of that array and then print out the requisite information in there. One more that I'll cover, and then we'll open it up for some questions here, is what we call an example of the Galileo public API here for any Galileo customers that are out here that need to affect this. So in this example, we are maintaining multiple states. So we've seen some examples of maintaining maybe a single state. In our create account here, which is typically the first step in this Galileo provider, we can see some tests here, but if we come down into the state, you'll notice 4 different state operations that are happening here. And this is a great point or place to point out the difference between an operation and a variable. So up to right now, we've been talking about operations. Operations are setting a key value pair or a state that will be maintained in memory inside of the mock API. A variable that we're seeing being used here, which is differentiated by this context of being local, is only available while this stub is matched. And the way we're using this here is that we are going to dynamically create an account number, right? We're going to create an account. That account number should be generated. We'll make use of our random value handlebar helper here to create a 9-digit account number. And then we're going to use that account number going forward as the context. So now everything else will be tied to this ACC underscore account number. So we only needed that account number briefly so that we could successfully reference the context going forward. So going forward now, we'll use this context tying a customer profile, a balance, and a listing of transactions, all tied to this account number being maintained in memory inside of this mock API. And then, of course, pulling open one of these value setting sections here, you'll see a very complex but powerful approach here where we're building out a customer profile based on the rules of this API, determining if the first name is not an empty string and is not null. Let's go ahead and capture the first name. And what we're doing in this particular example is building out a custom object, customer object for the customer profile, and then ultimately saving that into the customer profile. Okay, so you can see you can do a lot of powerful things with the stateful mocking inside of WireMock, replicating a lot of that business logic in your dependent APIs or the APIs that you depend on, whether they're internal or third party, really getting you to the point of it behaving just like the real system, but not having all of the dependencies of databases and infrastructure or performance, not being able to perform at the rates of TPS that you need, not being able to respond back and the timings that you need to do your performance testing. All of these pieces can now be solved, especially in these very stateful APIs that we often interact with, using WireMock Cloud's dynamic state capabilities or stateful mocking capabilities. Okay, so I'm going to transition to a couple of questions here. Ethan, you got anything lined up for me?
Yep, we absolutely do have a few questions. So we've got one. Can the context use fields included in the payload of a JWT token?
The context
Assuming it
use
means be
fields
included. Can the context use fields
included.
be included in the payload of a JWT bearer token?
That's a great question. It looks like that's coming from Paul here. So our full handlebar helpers library should be available. And if we, really take a look at our docs here, and we do have JWT specific helpers here. I'm just not sure about parsing out the pieces of everything that's in there. So, Paul, I think that's something I'll have to take away with our engineering team to really dissect there. If there is a handlebar helper that can help us parse the JWT, or other handlebar helpers can allow us to decipher the JWT that was passed in, then the answer would be yes, because the full handlebar helper library is available inside of the context modal. But specifically, parsing out different information from the fields of the JWT, that's something I'll have to dig a little bit deeper on.
Yeah, that's a great question and a great use case. So I'm kind of excited to get the answer, and I could see some utility there. If the answer is no, it's probably an enhancement we'll want to look at. But if it's yes, there's probably a cool blog that we should work on in that. I like that suggestion.
I agree.
So Simon asked, how long are the states persisted? That's another great question.
Yeah, that is a great question. So, the way that stateful mocking was designed was really geared towards shorter stint testing, right? We're not looking at storing balances and states in the long term like we would with a database. We look at this as testing scenarios. So typically using these, we're going to run through a set of scenarios, and then we'll want to zero everything back out. Once things pass or fail, we make changes. So a little bit earlier stage. So if I come over to our documentation here, find my right tab here, we can see a little bit of information talked about as far as the plan limits, which might some others might have asked some questions here. So what you'll notice is that state values are ephemeral, and that they're being stored in a least recently used cache, right? And then, of course, we're making a best effort to maintain them, but there's no guarantee about survival. So what's important to note here is that they're stored in memory. They're not written to disk. So anytime that memory is cleared, we would lose those particular states. Now, when is memory cleared? Now, as an enterprise customer, typically, your mocks are not going to sleep with an enterprise plan, which you would need in order for this capability to be unlocked or inside of the trial. But if we are doing an upgrade to the infrastructure, that would be a time where that cache would be cleared as we push updates to your dedicated infrastructure as an enterprise customer. Then all of those mock APIs are basically reset. That memory is cleared. So again, it's a best effort for us to maintain those states in memory. And then, of course, they will stay in memory until you hit the reset state button, you make the API call to reset the state, or there's an update being pushed to your dedicated infrastructure that requires the mock APIs all to be restarted and their memory cleared.
We actually have a related question to what you're talking about. We can button that up. So Simon said, what's the best way to reset state with an automated test? Should we create a reset state stub that will match the request? I think you were just touching on that.
Yeah, so that's a good question. So the same API call that resets a scenario is still applicable to resetting dynamic state. So if we were to come down into our mocking API here, and let's see if I can find it, we can see that we have our admin scenarios, and we have this reset post call. This reset post call should reset your dynamic states or stateful mocking memory cache as well. So this would be applicable to both scenarios, legacy scenarios, as well as dynamic state / stateful mocking.
And actually, I was chatting in the background with our engineering team on that question about the JWT bearer token. That is possible today. So I'll read these instructions we got from the team out. So you can use regextract to grab the JWT from the header, and then you can get the base64 encoded body with regextract, and then you use the function base64 to decode it, and then parse JSON to parse the JWT body into a variable. It sounds like a lot. We'll put it in the documentation for you, and I think we can probably clean that up as well, because I'm instantly pretty excited by the idea, but it's good to know that it is possible, and we'll get that out there as well. Another question. The config language that we use in the stateful mocks, that's handlebars.
Mm-hmm.
Correct, Dan? Okay.
Yes, yep. That's correct. So that is our, if you were to come into our docs here, and you look in this response templating section, you'll see a call out to pretty much the library of handlebar helpers that we're using. So you'll see here that this is handlebar JS, right? While you'll find many, if not most of the handlebar helpers here, I even haven't been with WireMock for almost a year at this point, and still discovering new handlebar helpers as I every day, I should say, right? One of the newest ones that I just discovered, I'll point this out. This was this tilde that you're seeing here. Maybe some of you caught that when I clicked on it before and are wondering what that was. This is a way to trim white space. So a tilde used in front of a handlebar helper will say, trim, this one will trim any leading white space, and the one at the end will trim any trailing white space when this value is actually calculated and stored. And the same would be applicable inside of your responses. Oftentimes, people using dynamic response templating might see that there's been extra white space added when they're using loops and control logic. One way to handle that without using the trim handlebar helper is to make use of these tildes to do the trimming for you. Very handy little piece there. Okay, awesome. I'll just make one call out here before we wrap up, Ethan. WireMock.io/academy. We've got a dynamic state video on there, 6.5 minutes. It's you'll see some of the same stuff that I've talked about here. Stay tuned for more and more content from our team. Maybe I'm stealing your thunder here, Ethan. I apologize if I am. Specific to dynamic state and stateful mocking, use cases for it, and maybe even some dedicated offerings around very typically complex third-party APIs such as the Galileo one, and how customers of these often use third-party APIs can get immediate value with some offerings and some detailed use cases.
Great. And the last thing I'll add is our emails are very straightforward. So Ethan@wiremock.io, Dan@wiremock.io. If you want to chat with us about this at all, if you have any further questions, feel free to reach out. We'd love to dig in further with you. Other than that, thank you all for joining. I hope you had a good time, and we'll see you in about a month for the next one.
Thanks all.